Go.
Okay, good morning. Today we will be doing exponents. I wrote that because it's a surfer thing and my brother surfs. Quick story about that. I'd be like, I wanted to buy a surfboard from him and he's like, I'll give you the bro deal. That's what all his neighbors do. Like, dude, give me a bro deal. And he was like, for you it'll be literally a bro deal. So I was like, cool. So I just wrote, brah, exponents, brah. Just gonna hit the waves and then get a chili cheesesteak, brah. And then go take a nap. It's my alternate life. Okay, ready for exponents. I know. Oh my God. The idea is, let's learn how to do it together so that when you see it, you'll know how to do it for the rest of your days. What do you think? What is this? Do you know the rules? What's this? Yes, go.
You add from the exponent.
Okay, so it's technically like you add, right? I shy away from the word add. This is, do we understand that this is a multiplication problem? Okay. As long as we understand this is a multiplication problem. This is x times x times x times x, and then 6 more here. 6 altogether. That makes x to the 10th. All right, so that's the first rule. Next. Right. What about that?
Subtract.
So again, we're going to put the quotes, unquotes. This is, many people think of this as we subtract these two numbers, but this is not a subtraction problem, it's a division problem. So I think of it more like canceling. Think of it like canceling, like this. A 1, 2, 3, 4, 5, 6. A 1, 2, 3, 4. And notice, what is x over x?
1.
1. A gone, 1, 2, 3, 4. How many left? Where? 2 on the top. So this becomes x squared. Yes?
We didn't do it enough. Yeah.
Oh, this is terrible. We didn't do enough.
We have to start
Now you
again.
have to start.
We have to start again? Let's pretend we did.
Okay.
Hi, welcome to Exponents, brah. You guys are so just like waiting for the next moment. Really, you're like those little dogs on the dashboard of the cars. And I always like hit the top of their head and they're like this. I know, you know why I'm reluctant? Because if I just yell it out, it's just kind of like, you know, out of nowhere. But we have to get our energy up, okay? So ready? I'm going to do it loud and you have to do it loud too. There's only one chance. We're going to get a yay English as a result. Let's do it anyway, okay? So do it loud. I'm gonna up my energy tenfold right now. Ready? Yay math!
Yay, math!
All right, nice. Don't let me down. Good job. Thanks for the suggestion. Okay, now we're resumed to where we were.
Yeah.
Okay, so this is x squared. And then the next one goes like this. I'm waiting for the yay English. So what will this be? Qu'est-ce que tu penses?
1 over x over 2.
Okay, now, the answer is 1 over x squared, which is the same as x to the negative 2. And we're going to talk about this. Let's do the cancellation technique. If we're going to do the cancellation, how many x's shall we write on the top? Yes? 4. Good. How many x's shall we write here? 1, 2, 3, 4, 5, 6. And 4 cancels with 4, leaving how many where? 2 on the bottom. So this becomes 1 over x squared. Questions about this? 1 over x squared. Okay. Now, if we were going to do, I'm standing in the way, if we were going to do subtraction, you know, like we did over here, 6 minus 4 is 2. If we were to do that, we would get 4 minus 6, which is what? Negative 2. Right. Yeah, we have visitors. So x to the negative 2. I knew it. They think they're cool.
That was like a whole to-do do. They like
I know,
set up and make a
yeah,
formation.
they totally
I thought they were
form
playing
it up.
musical chairs.
Yeah. When you guys see them in the hall, and then you know of people in that English class, we're like, good job. That was a good one.
You should
And
poke
then
your head
walk
in
away
there.
like this.
No, poke your head in there and do it.
No. Like, that was really good. Do a louder one. Every time. And then they walk around like, yeah, we do yay English too. They do that. And then like they're gonna come in with like noisemakers and like little poppy things, music and like bass. Yeah, English. And you're like, yeah, good one. Keep that up.
Like a gay English raid.
Yeah, English rated, yeah. Shakespeare. Okay, we're back. X to the negative 2. Does anyone know the rules for negative exponents? When you have a negative exponent, how shall we simplify it? Because I'll tell you now, negative exponents are not simplified. So this is not simplified, even though these two are equivalent. The rule is, when you have a negative exponent, you move it to the other side of the fraction and make it a positive exponent. Again, negative exponents move to the other side of a fraction and they become a positive exponent. All right, now we're going to jump into this hardcore. Here it comes. Master of disaster. Man with the plan.
Keep going.
Fixture with the mixture. Does anyone have another one?
Yeah, but it's inappropriate.
Thanks for holding on. Allow me to make the point. Allow me to make the point. Notice the numbers were picked on purpose. On porpoise. What happens? What's the difference between the fraction 27 over 18 versus the exponents x to the 27 over x to the 18?
9.
Anyone?
9.
What do you say? What's 9?
Well, 27 minus 18 is 9, and then for the exponent, x 27 minus x 18 is 9.
So, no, you're getting there. What do you think?
9 is the greatest common factor.
Okay, so 27 divided by 18 simplifies to what over what?
9. No, 3 over 2.
3 over 2, good. So 3 and 2. So get used to this. This is a good strategy. I like to just draw a line and get ready to fill it in. So we have a 3 and a 2. And now x to the 27 divided by x to the 18 is what?
X cubed over x squared.
No.
Just x to the 9.
X to the 9th, correct. Here's a way of seeing, yeah, we're going to say something?
No, cube.
Okay. 18x is here. We'll cancel with 18x's here, leaving 9. Cool?
So 3x to the 9th over 2.
3x to the 9th over 2. Questions about that? Yes?
Couldn't 3x to the 9th be simplified?
Simplified how?
By 3?
No, an exponent, it's like 3x, or 3x squared.
Oh.
You know, they can't be simplified. 3x to the 9th is just another one. Okay? All right, final rule. Okay. Do you think we're going just at the right speed? Too fast? Too not? Oh, we have attendance. Live programming. Pause it. 3x, yeah, it's different when you whisper it. 3x squared to the 4.
Oh.
Will you learn
no.
better?
Yeah.
Yeah, what do you think? What do you think?
Multiply the exponents.
Okay, so let's talk about the exponents first. Sure. It's x squared to the 4th. So that's x squared times x squared times x squared times x squared. What's that?
X to the 6. X to the 6.
X squared times x squared times x squared times x squared. What's that?
X to 8.
X to the 8. We just went over this one where you add the numbers here, correct?
Yeah.
All right. And now 3 times 3 times 3 times 3 is? No. 3 times 3 times 3 times 3 is 81.
Oh, I did.
Lovely.
Times 4.
Cool? Yes, was that a hand?
Julio.
It was a hand, but it was not directed in my direction. Okay, 81x to the 8. Any questions about this? What if this was negative? Will that change anything?
No.
No.
Oh, yeah, I know.
Negative 3 times negative 3 times negative 3 times negative 3 is positive 81. Okay, so hopefully you don't hate me yet.
Yes.
Well, not yet.
Are you ready for this?
See, now
You ready? Let's see. I'm gonna, if it was someone else, like any math teacher, this is what a math teacher would do to make you hate him or her. Prepare. Prepare your hate valves. I'm not a hater, I just math a lot.
Yeah, this might put strain on our relationship.
My goodness. Okay. Yes. Yes.
Oh.
Rev your engines. Voom voom. That's how my engine sounds.
Really?
Yeah, get that
Let's
shit
get
on.
that checked out. First distribute.
Yeah, first, let's bring this 2. There's multiple ways to do this. This is one way. Let's take this 2 and apply it to each of the 3 terms. So 3 squared is 9. X to the negative 3 to the 2. What do we do with powers to powers? What do we do with exponents? Multiply. X to the what? Negative 6. Powers to powers, we multiply. Powers to powers, we multiply. Y to the 8. Good job. I need more voices.
Okay.
Need more. 3 to the negative 3. And don't say, yeah,
Wait, no, 127.
okay.
Negative 27.
Yeah.
It's not negative 27, that's a common mistake. It's okay.
One of them.
Here's what I say. Let's just write 3 to the negative 3.
Are you sure you want to do
Yeah, first we'll write 3 to the negative 3. And then we shall see. X to the negative 6. Do you have erasers?
that? Yeah.
Okay. Take this, cross this off then, make it an X. I wanna demonstrate a point. Alright, so that's gone. So now this becomes X to the what?
Negative 3.
Negative 3. Erase! Wouldn't it be cool if your finger was an eraser? Like instead of a fingerprint? Just like, oh, I got it wrong!
Like Inspector Gadget.
Like Inspector Gadget, yeah.
Or it sucked when you're doing your homework. Like, whoops.
Yeah. Like, I can't write, it keeps erasing itself. Yeah.
No, you would use different hands.
Right, you different hands to write, yeah. Or it's like when you want to say like to someone, shh, don't talk. I'm like, why do I taste eraser right now? Y to the what?
Negative 30.
Negative 30. Okay, now, here's the recomendación. Take it up here. It's confusing?
No.
Okay. If it's ever confusing, stop me and tell me at the point it's confusing.
Wait,
Right.
so we got rid of the x squared?
The negative 3 applied to each of the 3 terms. Yeah, so negative 3 is here, here, and here.
Okay.
Are you sure?
So wait, so in the first equation it's not x squared anymore? You combine.
Yeah, it's not x squared, so this is x to the negative. Yeah. I wanted to change it because it became the same numbers, 6 and 6 element.
Oh. Okay, right. And then
Okay, any
you go
questions
top.
more? Okay, let's keep going.
Cancel itself out.
We drew the line. Now, focus on the top. Focus on the top. What stays and what moves?
The negative 6.
Does the 9 stay?
Yes.
9, we're writing again. Does the x to the negative 6 stay?
No.
Where does it go?
Down.
Goes down, x to the negative, x to the positive 6. Correct? We don't need it. Yeah, it's a good question. If we put a 1 here, we don't need it in this case because there's already a 9. If there was nothing left on the top, we would put a 1. Cool?
Cool.
Wait, why do you put it on the bottom?
Because the rules for negative exponents is that if you have a negative exponent on the top, it moves to the bottom and becomes a positive exponent in the side. Okay, so we did this one, we did this one. Does this stay or move? Stays. Y to the 8. Okay, so we did the top's taken care of. Bottom, does this stay or move?
Move.
Why does it move?
Negative exponent.
Negative exponent, so it becomes 3 to the positive 3.
Wait, I'm confused now.
Okay, see this?
Oh, wow.
Has a negative exponent, so it moves to the top of the fraction and becomes a positive exponent. Just like this was a negative exponent at the top and it moved to the bottom.
it's always opposite.
Yeah, think of it like a two-story house, and whenever you have a negative exponent at either floor, it has to go to the other floor and become a positive exponent. Yes?
So anytime the exponent outside the parentheses is negative and there's a real number in the parentheses, you just leave it as like 3 to the negative third instead of 1.
Like in this step?
Yeah, but like if it was different numbers, it would be the same.
If it was positive, you mean?
No, okay. Like anytime that is a negative outside the parentheses,
Right.
then you leave it like that. You try to have negative 27.
No, I'd recommend leaving it. I'd recommend leaving it. As an aside, hopefully you guys know this, we could have taken this whole thing and put it to the top and made this 3 positive 2. There's another way of doing it. Again, see this negative exponent, the rule for negative exponent is we'd have to move it. So we take this entire piece, move it upstairs, and make this 3 positive. I chose instead to do with you, taking the 3 in, one at a time, and then dealing with them each individually. All right, so we took care of this one. Does this stay or move? Move where? And becomes what? X to the third, so that's done. Stay or move? Move becomes Y to the 30. Okay, now hopefully this is more manageable. Just simplify. So yeah, what are the like terms? We have 9 and we have 3 to the third. What's 3 to the third?
27.
27. 27 times 9?
Oh, you multiply?
All multiplied.
240. 60.
Well, 27 times 9, 20 times 9.
243. 260. 240. 43.
243?
Yeah. 240.
Well, let's think about it. 27 times 9. 20 times 9 is 180. 7, 63. 63. So 180 and 63, 243.
That's my easy.
All right. 9 times 27. Okay, X's. We have how many on the top? 3. We have how many on the bottom? 6. So 3 cancels with 3, leaving how many where?
Negative 3 on the top.
Nothing on the top and 3 on the bottom.
X to the third on the bottom. X to the third on the bottom. Questions about that?
Yeah. Why?
Okay. Imagine a simple standalone problem where you have, when in doubt, write it out.
Oh, it's.
I want
stays on the
3. 1, 2, 3, 4, 5, 6. 3 cancels with 3, leaving x cubed on the bottom. So x cubed on the bottom. Follow-up questions? Feel free. This is your time. Okay. So we took care of the numbers. We took care of the x's. Y's. How many y's do we have where?
Y to the
On the top, we have
38.
38.
Y to the 38. So who would have thought that this simplifies to that?
That's the
Amazing.
answer?
That's the answer. I saw it the whole time. That's it. Yeah, you saw it the whole time, right? I think we can stop right there. I think it's good.
Is it?
You want to do one more?
No.
Not really.
Mixed emotions. Laughing because you don't want to do it, and that's cute because you're young youths of America and you don't want to do that much work. And sad because I'm a teacher and I want to inspire you. So it's mixed emotions. Bittersweet dark chocolate.
This is up to you. Want to do one more?
No, it's okay. The moment's lost. It would take a long time. We've reached our limit. How much?
20.
20. Perfect. Okay. Thanks, brah. We did the exponents. I caught a gnarly tube. X to the negative 3 is 1 over x cubed, brah.
It's not even.
Guys, it's morning time for you. Okay. Say bye, everyone. Bye. Bye.
Press that. Okay, squeeze. He lost his head.
Ow! Hurts! Hurts! Stop it!
Okay, stop.